Okay, let's do this practice with multiplying matrices. So in number 8, we have a matrix that has 3 rows and 2 columns. And then we have a matrix that has 2 rows and 2 columns. And so because the number of columns of the first matches the number of rows of the second, it is possible to multiply them, and the answer will be 3 by 2. Okay, so what we're going to do is take the numbers from the first row and multiply by the numbers from the first column. So 1 times 7 plus 2 times 0. 1 times 7 is 7 plus 2 times 0 is 0. 7 plus 0 is 7. Now we're going to take the numbers from the first column and multiply, the first row of the first one, and multiply by the numbers from the second column of the second one. And that will go in the first row, second column. So 1 times 8, 8, plus 2 times negative 1, negative 2. 8 plus negative 2, 6. Now we're going to go down to the second row, back to the first column. 3 times 7 plus 4 times 0. So 21 plus 0 is 21. And now we're going to go over to the second column. 3 times 8 plus 4 times negative 1. So 24 plus negative 4 is 20. Now we're going to go down to the third row and back to the first column. 5 times 7 plus 6 times 0. So 35 plus 0 is 35. And now we're going over to the second column. 5 times 8 plus 6 times negative 1. So 40 plus negative 6 is 34. And that's our answer. Okay, let's do another one. Okay, so in this one, we have matrices A, B, and C, and we're going to find the product of A multiplied by B minus C. So let's start by finding matrix B minus C. So 2 minus 2 is 0, negative 3 minus 1 is negative 4, 1 minus negative 4 is 5, and 0 minus negative 2 is 2. So there's B minus C. So now we need to multiply A and B minus C if we can. We have to find out if it's possible. Let's look at the dimensions. A is 3 by 2. B minus C is 2 by 2. So yes, it is possible because the 2's match, and the answer is going to be 3 by 2. So what I'd like to do is write them next to each other. Here's A. Here's B minus C. Okay, first row, first column, we get 0 plus negative 10. First row, oops, let's see if I can separate those. Just make that one, pause. Make that one. Hopefully they'll move separately now. Okay, first row, second column. Negative 12 plus negative 4 is negative 16. Now let's move down to the second row, first column. 0 plus 20 is 20. And then let's move to the second column. 0 plus 8 is 8. Now let's move down to the third row, and first column. 0 plus 25 is 25, and then third row, second column, 4 plus 10 is 14. All right, we have a few more practice multiplication problems. Here we have matrices A, B, and C. Let's see if it's possible to multiply A and B. So the dimensions of A, 4 rows, 1 column. The dimensions of B, 1 row, 4 columns. Okay, so yes, it's possible, and oh my goodness, the answer is going to be 4 by 4. Whew, let's see if we can get this to work. So we have 1, 0, negative 1, 4. 2, 1, 3, negative 2. So remember, we go across a row, down a column. So we only have one element in each of those. 4 by 4 answer. Okay, 1 times 2 is 2. Now we go across the same row, but down the next column. Oops, got to get those to separate again. See if I can get those to cooperate with me. That one, and then I'll pause, and then this one. Okay, so across the first row, down the second column, 1 times 1 is 1. Now across the first row, down the third column, 1 times 3 is 3. Now across the first row and down the fourth column, 1 times -2 is -2. Now moving on to the second row. Across the second row, down the first column, we get 0. And guess what? It's going to be 0 times everything. 0 times 1, 0 times 3, 0 times -2, so that whole row is going to be 0. Now let's move down to the third row. Across the third row, down the first column, -1 times 2, -2. Down the second column, we get -1. Down the third column, we get -3. And down the fourth column, we get 2. And now we're ready for the fourth and final row. Back to the first column, 4 times 2, 8. Moving on to the next column, 4 times 1, 4. Moving on to the next column, 4 times 3, 12. And moving on to the last column, 4 times -2, -8. Okay. Well, that one was cool. The next one is b times a. So we've reversed the order. Question is, can you do that? Will you get the same answer if you reverse the order? Let's see. B is 4, B is 1 by 4, right? 1 row, 4 columns. A is 4 by 1, 4 rows, 1 column. Is it possible to multiply? Well, yes it is, because those numbers match. What will the answer be? 1 by 1. Oh, that might be kind of nice. So let's go ahead and write those together. There's B, there's A. We're going to go across the row, and there's only 1 row. Down the column, and there's only 1 column. So we're just going to get 1 element in our 1 by 1 answer. So we have 2 times 1, 2, plus 1 times 0, 0, plus 3 times -1, -3, plus -2 times 4, -8. So that was 2 plus -3 plus -8. That's -9, right? Yeah, okay. -9. Hope I did that right. Sometimes adding in your head sometimes we make mistakes. Okay, how about b times c? First of all, is it even possible? Remember, b is 1 times 4, 1 by 4, 1 row, 4 columns. C is 4 by 2, 4 rows, 2 columns. Oh yes, it is possible because the 4's match, and the answer would be 1 by 2. I'm just going to leave that one because I know this is taking a lot of time and we still have a couple more things to do. But if you were struggling and you wanted some help with that, let me know. And then how about c times b? So let's think of c first. C is 4 by 2, 4 rows, 2 columns. B is 1 by 4, 1 row, 4 columns. Well, nope, those do not match, so we cannot multiply them. Not possible. So that should answer a question for us right there. If b times c is possible, and c times b is not possible, then what do you think about this? Is matrix multiplication commutative? If you reverse the order that you're multiplying in, will you always get the same thing? If they're commutative, then you would always get the same thing. And we can see that the answer to that question is no. B times C was not the same as C times A. One was possible, one was not. And if we go back even further, we had B times A, which was 1 by 1. We had A times B, which was 4 by 4. Both were possible, but they were not the same thing. Now, there may be times when you multiply two matrices in either order and you do get the same thing, but those are special cases. It's not always true. And if we were curious about the associative property or the distributive property or other kinds of properties that work with real numbers and wondering if they work with matrices, we might just have to start by investigating with numbers, and that might give us a sense for what's going on, and then after that we'd probably have to try to investigate in general with just using letters. I don't want to spend a ton of time on that though, because I do want to take a couple minutes to show you how to use your graphing calculator to do matrix operations. So here's my graphing calculator. Let me go back to the home screen and make sure that's clear. Now you will notice that right below the math menu where you have your x to the negative 1 button, or right below the math button I should say, you have your x to the negative 1 button, and the second function of that is matrix. So you press second and then the x to the negative 1, and that takes you into the matrix menu. Let's say you want to edit matrix A. So go over to edit, select A. Let's say we want this to be a 2 by 2 matrix. Type in the dimensions, and then let's type some numbers in. Let's say it's 6, 2, 0, -3. Okay? Now to go back to the home screen, you quit, and quit is second mode. Now let's say we want to type in a second matrix. Back into the matrix menu, second, x to the negative 1, over to edit, and down to B. Press enter. Let's make this also a 2 by 2 matrix. And then suppose the elements are 1, 2, 3, and 4. Let's just keep it simple. Okay, if you want to go back to the home screen, you quit. Second mode is quit. Now let's say we want to add matrices A and B. So into the matrix menu, select A. It shows up on your home screen. Plus, into the matrix menu, oops, I did the wrong menu. Into the matrix menu, select B. Shows up on your home screen. Press enter, and there you have the sum. Okay, you can subtract, you can multiply. Let's try that. Into the matrix menu, choose A. You don't have to put a symbol for multiplying. Into the matrix menu, select B, and then there you go. Now, at times, you might end up with decimal values there, and if you want to change those to fraction, like let's say, for example, I had 1/3. My scalar is 1/3, and I'm going to multiply that by matrix A. So 1/3 times A. Okay? So that doesn't give me all integer values. One of those values was a non-integer value, and it's a rational number, but the calculator by default puts it in decimal mode. Well, I don't like that very much, so I'm going to press Math. Choice number 1 is change to fraction. Press Enter, and it changes it into a fraction instead. You should get used to using that change to fraction button. It's really handy. You can use it for all different kinds of things. It'll even reduce a fraction for you. Let's say your fraction is 12/80ths, and you just don't feel like reducing that yourself. Just do 12/80ths, Math, change to fraction, enter, bada boom, bada bing, it's 3/20ths. Okay, so I think that takes us through everything I had hoped for, and here is today's assignment. That was a lot of video today. Thanks everybody for your attention.